Hello everyone, hope you guys are doing well. So today we will be continuing on where we left um, with our journey in computer networks. So okay, now we were um, basically trying to understand the network models. So network is basically a combination of hardware and software that sends data from one location to the another. Now the hardware consists of the physical equipment that carries the signals from one point to the another. The software consists of instruction sets that make the possible services that we expect from a network. So what he's trying to say is basically, um, so for example, when you are using a phone, right, it is basically the wire that is going to carry the signal, and then your phone might be programmed in such a way that when you dial the keypad, the the numbers are entered, and then when you press on call, like it makes a call using that network. That is basically what both hardware and software working together. When we compare the task of networking to task of solving a mathematical problem with a computer, now basically he's saying, okay, it's basically a problem where you need the hardware and the software. However, it is a very task. If the hardware is only involved, we would need switches for every mobile location to store and manipulate data. The problem solving is much easier if software is available. At the highest level, a program can direct the problem solving process. The details of how this is done by the actual hardware can be left to layers of software that are called by the higher levels. Now compare this to a service provided by a computer. For example, the task of sending an email is basically a software, and then it is sent using an hardware device. At the lowest layer, it is basically a signal or a set of signals that is sent from the computer source to the destination computer. In this chapter, we give an idea of how layers of network and discuss the functions of each. So layers. Now, when we use the concept of layers as an example, let us consider two friends who want to communicate through postal mail. The process of sending letter to a friend will be complex if there were no services available from post office. For example, now see what are the different steps. So these are two people. This is the sender, is the receiver. The first is the sender is going to write the letter, put the envelope, drop it in the mailbox. The postman is going to come, take the letter from the mailbox, carry it to a sorting facility. Okay. From there, it is then get taken to that city where the person lives. Then it is carried to his nearest post office, his nearest post. Then he comes and picks it from his mail. So as I see, there are different types of tasks involving a sender. Okay. Now, according to our analysis, there are three different activities at the sender side and three activities at the receiver side. The task of transporting the letter between the sender and the receiver is done by the carrier. Something that is not obvious immediately is the task that must be done in order given to the hierarchy. At the center side, this letter must be written and dropped in the mailbox, and then before it is picked by a post person who carries the letter, takes it to a sorting facility, sorts according to the city, goes into that city, and then goes to it will go to the mailing facility. From there, it will go to his nearest post office or wherever he has his post box, and then from there it will be picked up by the receiver. Now each layer at the sending side uses services of the layer immediately below it. So yeah, so if you imagine, the person has to send, the postman has to collect it from the layer above it. So the lower layers basically are using going to use the service of the higher layers. Now the layer model that dominated data communication networking literature before 1990 was open source data communication model. Everyone believed that OSI model will become the ultimate standard for data communication, but then this not now happened. TCP/IP became the more prominent commercial one which is being used. In this chapter, first we discuss the OSI model and then we concentrate on the TCP/IP as a protocol. So OSI model, this was established in 1947 by the International Standard Organization as a multinational body dedicated to worldwide agreements on internet standard. An ISO standard that covers the expressive network. It's an open source interconnection OSI model. This is basically a more theoretical model, how communication between different layers happens. Now it is not a protocol, it is a model. Remember, this is a model. Now we are just going to understand how the communication takes place. Now OSI has 7 layers. So starting from this, the application, presentation, session layer, network layer, data link, and physical. So it can also be written as all people. All people seem to need data for physical communication. Now layered architecture. The OSI model is composed of 7 layers: physical layer, data link. Okay, so physical layer, data link, transport, session, presentation, and application. Okay, figure 2.3 shows the layers involved when a message is sent. This is okay. This is I'm talking about 2.2. So in 2.2, basically there are 7 separate layers. Then figure 2.3. Okay, so this is how it's going to happen. Okay, let's first read what he's saying. In developing the model, designer distill the process of okay. The OSI model is composed of 7 ordered layers: physical layer, data link layer, network layer, transport layer, presentation, and then is the application. Now, figure 2.3 shows the layers involved when a message is sent from a device A to device B. As the message travels from it may pass through many intermediate nodes. These intermediate nodes usually involve the first 3 layers of the OSI model. Now, in developing the model, the designer distilled the process of transmitting data, its most fundamental elements. They identified which networking functions are related users and collected those functions into discrete groups and became layers. By defining and localizing functionality in this fashion, the designers created an architecture that is both comprehensive and flexible. Most importantly, the OSI model allows complete interoperability between otherwise incompatible systems. Now, within a single machine, each layer calls upon the services of the layer just below it. Layer 3 uses the services provided layer 2, and layer 2 provides the services for layer 4. Between machines, layer X is on one machine communication with layer X on the other. This communication is governed by an agreed series set of rules and protocols. Now, peer-to-peer process. Now, at the physical layer, communication is direct. Devices send the stream of bits to device B. At higher layers, however, communication must move through the layers and then backward. Now, each layer is sending as its own information. The message is and passes the whole. So, what is happening is, so the data, each layer keeps on adding some extra information to it, so then eventually the packet size will increase. Now, interface between the layers, the passing of data and network information down through layers of the sending device and back up to the layers the receiving device is possible by an interface between each pair of adjacent layers. Each interface, so basically there are interfaces between the layers. Now, organization of layers, the 7 layers can be divided into 3 groups: layer 1, layer 2, and layer 3. So then that is physical, data link, and then network. They deal with the aspects of moving data from one device to another. Layer 5, 6, 7 is session, presentation, application can be thought of. Okay, so what he's saying is layers 1 and 2 and 3, that is physical, data, and network, are grouped together. They are responsible for establishing the communication: physical, data link, network, and transport. Then 5, 6, 7. Okay, this is only till network. 5, 6, 7 is the actual transportation that happens. That is when the data moves from point A to point B. So then they are presentation, session, and application. Then is layer 4, the transport layer is deemed out. It is basically things that is used to that connects the top 3 layers with the bottom 3 layers. The upper OSI models are always implemented in software. The lower layers are combination of hardware and software. Now, figure 2.4 gives an overall view of the OSI. So for now this is okay. So first this is the D7 is basically the original layer, data. Then as we keep on moving through the layers, the size of the packet will keep on increasing. Like every layer will add its own information to the layer, and as you keep on adding the information, the eventual size of the packet will be more. Then we go back. This is the transmission medium. So now this is basically how you represent data, right? 1-0 in an electrical signal. You can represent it using Manchester. There are various types of coding. So now then you come here. Now here is basically when you start removing or unpacking the headers. Then this is when eventually what data or what information the user sent has been received to the receiver. Okay, upon receiving a destination, the signal passes into layer 1 and is transferred back into digital format. So now here when you are going, this is electrical signal. When it's transferring, getting transferred, or electrical or light, depending upon the transmission medium used. Generally, these days we have optical fiber. So okay, now encapsulation. The figure 2.3 reveals the information data communication in the OSI model. Packet is okay. So initially it is a packet and a header. At layer 7, it's encapsulated in a packet. At level 6, the whole packet at level 6 is so as we in other words, the data portion of a packet n-1 carries the whole packet from a level, and this concept is called encapsulation. Now what does figure 2.3 reveal? Figure 2.3, this is 2.4. So he's trying to say is something is getting encapsulated. I don't know what. A packet at layer 7 is encapsulated in a packet at level 6. How is the higher layer? Device A to device B. What is he trying to say? Encapsulation. What kind of encapsulation are we doing here? This is we went ahead. In the OSI model, a packet at level 7 is encapsulated in a packet at level 6. The whole packet at level 6 is encapsulated in the packet level 5. So as the packet keeps on moving. Oh, so what will happen is the header will attach on top of, suppose I'm moving from, so this is my data, right? Now see, remember D6 is this encapsulated plus the header. What is D5? D5 is this header D plus D6 is D5. What is D4? D4 is basically D5 and H5. The entire is getting encapsulated in the output, and then we keep on removing the encapsulations over here. Okay, fair enough. Now our first physical layer. Physical layer is basically a physical connection. The medium could be anything. It could be a coaxial, it could be a fiber, depending upon the ISP you are using and depending upon the connectivity they had. Remember always, physical layer will at the sender side will convert digital to electrical, and at the receiver side it's going to do exactly opposite. Convert the electrical back to 1 and 0 digital. And representation of zeros and bits. The physical topology is how devices are connected, transmission mode, full duplex, how communication is taking place, etc. etc. This is at the data link layer. This is at the physical layer when there is actual physical connection, not data link. Now what is the so remember, physical layer does not do any error checking. So it's the responsibility of the data link layer to do the following task. First is it will remember physical is so before we get to the physical, we should know there are different types of addresses, right? One is the IP address. It is used to recognize a network. For example, if you are a school, right, you will take an you will purchase an internet from the ISP, and then using the router you will like identify which devices should I send the packet to. So that is then using the MAC address. So here we do the actual physical address. Remember, IP is a virtual address, and MAC is basically the physical address of the device. Now this is given by the network interface card. Sorry, NFC. The NFC has these things. Now framing. So now it will do, so basically what all problems can occur. So like if we send the data like continuously, then the receiver won't know like when is the data coming, and suppose if there is an error, then in the medium, the receiver should know that error is basically when you send a 1 and the receiver gets it a 0. Ideally the receiver should, you should send a 1, the receiver should also send a get a 1. Now this error, so what we do is instead of sending the entire data, we do framing and send it in forms of frames, and then we add certain bits so that the receiver can know at the reception time whether there was any error or there is not any error. Now remember, this is the entry point of the data packet. So in the receiver side, the device that operates a data link layer is the modem that you get from an ISP. That is basically working at the data link layer and performing all the error correction and doing the framing. Okay. The access control. Now into more flow control is basically how, and also now the data is with the sender is saying should be synchronized at which the receiver is receiving, right? There should be a synchronous operation. It should be synchronized, right? That's basically flow control. And then when we have multiple devices, we will basically do which kind of device has if suppose I have a Wi-Fi and I have 3 devices, so now there should be a mechanism in the modem to know like which data should it send first. So that is again done by the data link. Okay. Then is the network layer. Now this is basically right now we are this is also it is so in data link we also say it can hop to home delivery, because we are sending from the end will be from the sender, and then it will directly end to the receiver, so it will be hop to hop, like it will keep on hopping between various links. Hopping is basically jumping, so it might choose which path to take to reach the receiver. And then is the network layer, and the network layer is basically the source to destination delivery. Now it ensures that the delivery, that means the IP by source is basically which network should I enter. For example, doing the logical addressing, routing, and checking, and then checking to which computer is the data intended to. Again, that will be done at the network layer. Now the transport layer. Now this layer is the one that is going to actually establish the communication. So it is called as process to process delivery. Network layer will oversee the source to destination of packets. It does not recognize any relationship between it. In a transport layer will ensure that the whole message arrives in intact, and the transport layer on the other in order. It will see whether there is any error control, flow control, source and to the source to destination level. Now other responsibilities are transport layer, service point, addressing, segmentation. When we study each and every layer, we will then do why we will like why and what. Okay, now session layer. Session is basically if the services provided by the first 3 layers are not sufficient, then the session layer is the network dialog controller that establishes, maintains, and synchronizes. It is a session layer is responsible for I say dialog. A session is generated. A presentation is basically with the syntax or information between two. Presentation is so after presentation is we are going to give the application layer, right? So we will be converting it back to data. How to present the application layer. So now at the receiver end, this will be like which application requested for this data, like which program or which application in the computer system will be required. So like to sum it up. Okay, now let's see the summary. So first is the application. Now it is the messages, I mean the stack behaves in a different way when you are at the receiver level, and then when you go at the center side it kind of behaves in a bit different level. Now this is when I'm in the center side. The first layer that is going to be in the center side is the receiver needs to first request for the data, right? So the request will be sent by the receiver. Receiving say okay, sender, please send me the data. Okay, and then once the request is sent, now I'm going in the center side. So then the actual connection between the sender and the receiver is using the physical layer, or the physical wire. But before that we need to check whether when we transmitted the bits in the physical using the actual wire, whether there was any error or not. So then what we will do, we will organize data into frames, and then we will do the hop to hop delivery. We will put certain bits or certain patterns for error check. At the receiver side, we will check this whether the transmitter had those proper bits or followed the proper sequence, if there is an error or not. Now the network is basically in the sender level is reliable for so network layer is going to check for the actual, like, which network. So it is going to identify to which network, that is it is going to do the IP addressing, which network should be the packet sent to. And then at the receiver level, at the network layer, it is going to move from the modem to which device, remember, and that information at the data link, that is provided by the data link at the receiver using the MAC address. The transport is basically when we actually establish the communication that is between the sender and the receiver. The actual communication is established. It should be something, right, like transport. It refers to how the packets will be delivered from the source to the destination, like what part should it take, basically transportation. And then okay, so the packets between the sender and receiver, there should be like an automatic timeout, right? So a session needs to be created. If there is no session, then the receiver will wait all its lifetime. Now application is basically which device or which specific application requested for the data identified using the port number. Let's see if we have summarized it correctly or not. New incognito. The first thing that we said is what happened to my search engine. I'll check that later on. Okay. The OSI first thing we studied is it's like the layer is very different. Let's start. A physical layer at sender will do digital to electrical, and at receiver it is vice versa. Okay, this is correct. Then we go to data link at sender does framing, adds bits so that, and then the physical MAC addressing. on the device and have the receiver looks for the error correction bits and verifies if data received is corrupted or not. Yeah, this is data link, and then network layer and sender. Which network data send to done by using IP address. Then I'll use the IP address. Okay, perfect. Transport is when deal with which path should be taken to which. Like which path, right? So transport layer, okay, routing also is done by network. Transport layer establishes the communication. So then I'm going to like when the connection, actual connection establishment, like the virtual random host to host. Host to host refers to end-to-end communication between two devices or network. The devices can be in transport is when we do the actual communication between two devices. Transport layer does that. The session layer maintains sessions, ensuring timely delivery. That there is something a session. Okay. And then is my presentation layer is like formatting the data to be served to the application which is running. Okay, now see when we say session timeout, are you referring to session layer or so in many websites you have an option called as timeouts. Then you do this website timeout is it at the session layer Practical use case of the most practical one will be TCP, right? Yeah, session layer and application layer between layer 5 and layer 7 we will be doing that thing. So in TCP, so okay, now then the TCP IP protocol. So this is the most practical version of the OSI model being referred. So the three layer, that is application, presentation, and session, have been clubbed together. So there is no so then we say that layer 5, layer 6, and layer 7 are going to be the same. Now, why are all possible? We can get a congestion. Okay, let's not debate that right now. Layer 6 layer where we need to use the let's check another time. Now addresses, the types of addresses. Physical address is the actual address of the device. Logical is like the IP address. Port addresses is basically the address of the application running on the physical device that to which the data needs to be sent. And I had a doubt. So my doubt was, okay, now browsers are a very funny thing, right? Some browsers keep only some tab. Okay, it kind of works on the operating system level, I would say. I guess it does that. So what is a YouTube video even when it is in I have a YouTube video playing in background still plays? Why? So that is related to, is it's something related to OS browser capabilities, like are we performing section? When we have two tabs open and one YouTube is being played. Is this kind of, but then that happened very fast. Yeah, switching is still happening at that level as well. Sometimes it does not run. What it does is kind of it waits if that streaming, if it's still buffering, or it will wait for it to buffer in the, yeah. So back in olden days, I remember when the net speed was not so that, what we used to do is we used to pause a video in a tab so that the it keeps on downloading and the buffering goes off, and then in the other, till the time we used to surf the web on the other tab. So once the downloading or once the loading is complete, we used to just switch back and then watch it. That is when before 2015, that time web was not that fast. Luckily now we have a very fast web. So yeah, it is not, it happens, but the switching is so fast you won't even come to know that the switching has done. Port addresses are basically the physical or the actual application requesting that. And then these are basically different protocols at different layers. Each layer, okay, so since we say, now one more thing, since we are using the TCP stack and layer 5, 6 and 7 are merged together, you can say session is also at that layer. Yeah, TCP OMR both, they are clubbed. Then we say it is happening at the application layer, but inherently what we are trying to say is it's working at the session layer. So that's why when I searched first for establishing a session, actually it happens in the session layer, but then in the practical usage those three will be clubbed. So application, presentation and session, both three are clubbed, so you won't have a specific layer dedicated to it in the TCP IP stack. OSI is basically like a model, and then basically we just take. Yeah, so what will happen at each layer can say whether which layer will the device pass. This will be more clear when we start going into each level, and then I'm checking this physical layer. Okay, so this will have Manchester coding. Yeah, so that's all for next. We will continue with the physical layer. That's all for today. Hope you guys were able to understand the TCP IP model and OSI model, and then we will be going in depth in each of these models. Thanks. Have a good day. Bye bye. Take care.